Hello class, this is Miss Edwards and this lesson is on solving problems with functions and graphs. Make sure you have your notes because you're going to copy down some information. The first thing I want you to copy down are these steps, which is how we solve problems using our functions and graphs. So firstly, we need to find key information in our problem. And like always, we should box or somehow identify, either in a highlight or a color, what's important. The second thing that we need to do is write or identify a function. Sometimes it's given to you in the problem, sometimes you have to figure out what that function is. So it depends on the problem, which means you need to think logically. The next thing we need to do is we need to identify or find coordinate pairs, and we do this using a function table. So don't forget that when we use a function table, we're able to find our coordinate pairs really easily. So we'll be using that skill as well. And if the question asks us to, we need to either make a graph or sometimes we use a graph to find the answer. It just depends on the question. So sometimes we need to make a graph, which means plotting on a coordinate grid. And the very last but the most important question is, after you have your answer, is my answer reasonable? We must ask ourselves. So before you move on, take some time and make sure all of this is copied into your notebook. Okay, so our first example problem is this. The relationship between Fahrenheit and Celsius is given by this formula right here. If it is 15 degrees Celsius, what is the temperature in Fahrenheit? So over here I have my steps to remind me what I need to do to solve this problem. And always the first thing I need to do is box key information. So in the first sentence, it tells us the relationship is given by this formula. So this formula is really important. I'll put a box around it too, because this is our big clue, our big piece of information. If I go back and read the second sentence, it gives us the prompt for our question. If it is 15 degrees Celsius, what is the temperature in Fahrenheit? So we're trying to go from Celsius to Fahrenheit. Well, let's look at our formula for a second. I have F in here, and I have C in here as a variable. So I can determine that F is equal to Fahrenheit, that's what that stands for, and C is equal to Celsius. So now I have determined what these variables stand for. So I have found my key information and the functions given to me. Well, finding coordinate pairs, that's essentially what the question is asking us. They're saying if C is 15, what is F? We want to know what that is. Well, this reminds me of an X and Y coordinate, but instead of using input as X, our input is now C. And instead of using an output of Y, our output is now F. So essentially, this is just our regular coordinate function, but we've used different variables so that it matches the problem. Okay, so knowing that, let's plug some things in. We know that it's 15 degrees Celsius, so I'm going to rewrite my formula. F equals, we have a fraction, 9/5 times 15 plus 32. So I've plugged in 15 degrees Celsius into this place where the variable is, and now I've rewritten it down here in my formula. Okay, so let's continue on. I'm going to minimize this and just move it up here so we have a little bit more space for a formula. Perfect, okay. So now what I need to do is find my coordinate pairs essentially, but instead of using my X and Y, I'm going to use my variables for this problem, which are C and F. So I'm making a function table to find my coordinate pairs. The first input, C, which is given to us right here, right? This is what we're trying to find. Our first input is C. is 15. So let's put a 15 in for our input, and we need to use this formula to find our output. So first of all, we need to remember PEMDAS, PEMDAS, in order to solve this problem. And we need to see that we need to do multiplication and addition to solve this problem. So firstly, we need to multiply these this fraction by this whole number. So let's remember multiplication of fractions. This 15 is essentially 15 over 1. And the rule for multiplication is we multiply straight across. But before we do that, I'm going to look at my problem because I noticed something. I noticed that 15 and 5 have something in common. They can both be divided by 5. I can reduce these by 5. So 15 divided by 5 is 3. 5 divided by 5 is just 1. So now my problem is so much easier to solve. 9 multiplied by 3 is 27, and 1 multiplied by 1 is 1. So this just becomes 27. Now let's not forget, we have to plug this back into our formula because we still need to do our addition. So plugging this back in, all we need to do is say f equals 27 plus 32. And I'm going to try and do this somewhat mentally. 7 and 2 are both in the ones place, so I know that's going to be a 9. 2 and 3 are in the tens place. Add those together and I get a 5. So here's my final answer. F equals 59. So let's plug it back in and ask if it's reasonable. If my input of C is 15, my output is going to be 59 degrees. Now, just using common sense, asking, is this reasonable? I know if it's 15 degrees out, it's pretty cold. 15 degrees Celsius, I know that's pretty cold. And I know that 59 degrees Fahrenheit is pretty cold. So that, as far as I'm concerned, that logically makes a lot of sense. And if we look at the numbers too, if we go back and look at this formula, 9/5, 9 over 5, this is an improper fraction. It's greater than 1. So when I'm multiplying this numerically, 15, I'm going to be multiplying it by something greater than 1, which is going to give me a number greater than 1, and I'm adding 32. So these numbers logically match up, make sense as a good answer, so I think my answer is reasonable. So here's another example that we might see. Al used a graph to put his house at 0, 0. Frank's house is at 2, 2, Emma's is at negative 2, 3, and Lola's is at negative 1, negative 2. According to the graph, who lives closest to Al? So all we need to do is plot these points and figure out which one is closest. So Al's house is at 0, 0. This is at the point of origin, so we want to make sure that we understand he's in the center. And let's just put an A to remind ourselves that it's Al's house. Frank's house is at 2, 2. So using my estimation skills, I'm going to run to, remember, run before you jump. So I'm going on my x-axis first, then my y-axis. So I'm going over 2 and up 2. And I'm just trying my best to place these as accurately as possible. Okay, so this point is 2, 2, and this is Frank's house. My next house is at negative 2, 3, so this is going backwards on my x-axis. Negative 2, I'm running backwards 2, and I'm jumping 3. I'm jumping positive 3, so 1, 2, 3. It's going to put me here. And I want to label that also, negative 2, 3. And this is Emma's house. And Lola's house is negative 1, negative 2. So over 1 on my x-axis backwards, negative 1. And then down 2. It's going to put me right here. So this is negative 1, negative 2. And this is an L for Lola. So now I need to determine who lives closest to Al. And just by looking, I would say that Lola lives closest to Al. But let's figure it out based on our mathematical reasoning as well. So if I look at this, I can see that starting at 0, 0, I need to go -1, I need to jump over 1 space, and then I need to go down 2 places, 2 units to get to Lola's house. So this gives me a total of 3 moves in order to get there. 1 backwards and 2 moves down. So that's 3 moves in total. So I'm just going to notate that off to the side that it takes kind of 3 jumps to get there. Now let's go back and look at Frank's house, because Frank's house looks like it's also pretty close. We want to check and make sure. So if we start at Al's house again at 0, 0, now we're moving 2 over, +2 on our x, and then +2 up on our y. So those moves, 1, 2, plus 1, 2, this is going to be a total of 4 moves in order to get to Frank's house. So this takes me 4 jumps, 4 moves, however you want to think about it, 4 units in order to get to this place. And just for the sake of clarity, let's look up here at Emma's house. Emma's at -2, 3. So starting at 0, 0, I'm going backwards 1, 2, and then I have to go up 3. 1, 2, 3. So 2 plus 3, these moves, this is 5 moves altogether. So she's the furthest away with 5 jumps. So I have to use my logical thinking here. And when I see that Lola's house is the closest, I have to be able to prove it. And the way I prove it is looking at the number of spaces. So she only needed 3 spaces, 3 jumps, and we can kind of just draw this out here. 1, 2, 3 in order to get to her place. So this distance by default is going to be the closest distance. So who lives closest to Al? Lola lives closest to Al.